Again, it's time to apply what we learned. We're going to apply our newly gained knowledge about API routes to this events project we've been working on throughout this course. In detail, in this course section, we are going to add a newsletter registration flow, a component that allows a visitor to enter an email address and then stores that email address somewhere with help of API routes. And we're going to add a comments feature where you can comment on an event. So we'll also add a form there. And when the form is submitted, that entered comment data should be stored on the backend with help of API routes. And when we load a single event, we also want to be able to load the comments when the user wants to view the comments section. Now we're going to add and build the front end together. So we're going to add a couple of components together, but thereafter, after the next lecture, I challenge you to try adding those API routes on your own before we do that together and before we then also see how we could talk to a real database. So lots of features to add, lots of topics to cover. Let's dive in. Now for this course section, I updated our project code a little bit. You find this updated snapshot attached. What did I do? I added a new input folder in the components folder. So in the components folder, there is this new input folder, which contains a bunch of components which we're going to need in this module. These are all regular React components, no page components, which we are going to use for fetching user input and for then talking to the API routes. Now I have not added any API routes. The only other changes I made, besides adding these components, is that I'm using these components. In the events folder, in the pages folder, in this event ID component, I added the comments component here at the bottom of this JSX code. And in the Next.js file, so in the homepage component, there I added the newsletter registration. So if you install all dependencies and you run this updated snapshot, then on the starting page, you will see that email, this newsletter sign up part here. And if you explore a single event, there, if you scroll to the bottom, you'll see this show comments button, which you can click to view the comments form and some dummy comments, which we're going to replace with actual comments throughout this section. Now that is the starting state. And now I got a challenge for you. I want you to add a couple of API routes that handle the newsletter sign up, so that in the end handle an incoming email address, and then for the moment maybe just log it to the console, so you don't need to add any code that writes to a file or talks to a database, though you can also do that as an extra exercise. But for this task here, just make sure that you accept some request from which you retrieve the email, and make sure that such a request is then sent from the front end, from this newsletter registration component here in the registration handler. Make sure you send the request to that API route which you should add. You can also add validation for the user input to check whether the entered email was valid, but that is up to you and not something you have to add. Now that is the first challenge, the first task. It's not the only one though. We also got this comments section, and there I want you to do a similar thing. Add another API route that allows users to submit comments, and make sure that this API route is kind of dynamic, that the ID of the event to which the submitted comment belongs is part of the URL of the API route. So you'll need to create a dynamic API route here. Then again, handle incoming requests and make sure you extract that submitted data. and also handle the case that a request is sent to fetch the data. So you will need to handle two different HTTP methods. For the newsletter API route, it was only one method. You should handle post requests there. But for the comments API route, you should handle two different HTTP methods. Incoming post requests, which add a new comment, and incoming get requests, which fetch comments. Again, for the moment, it is enough if you just log the data, if you just log something in your API route. You don't need to write any other logic. Just return some dummy data in the get request case, and make sure you do send data and fetch data. We have this add comment handler in comments.js where you should send that comment data to your API route, and then also find a way of fetching comments when the list of comments here is shown. So when that comment list is shown, make sure you then fetch comments from the API route. And again, for the moment, it's okay if you just return some dummy data there. Just make sure you implement the base logic and you add those API routes. Now, definitely try it on your own first. In the next course lectures, we're going to add those features together step by step, and therefore, of course, also have a look at those lectures once you tried it on your own to see how I solved it and to compare your solution to mine and maybe improve or fix your solution if you got stuck somewhere. And with that, let's dive in. Okay, let's now solve this together. We want to add a couple of API routes here so that we can have our own server-side logic which is detached from rendering pages. And you'll learn how that works. In the pages folder, you add that special API folder which has to be called API. And in there, you can now again create any file and folder structure of your choice to define the different API routes and the paths leading to those routes you want to use. For example, we could add a newsletter.js file for the newsletter related logic. Then you learned that an API route in the end just is a function inside of that API route file, which you should export like this. And this function receives a request and a response object, automatically passed in by Next.js when it executes this function for incoming requests. Here we can then check the request method, for example, to only proceed for post requests. And we can do this here for the email registration, because whilst this is the only kind of method I want to support here, I want to make sure that no other method triggers any logic here. So I explicitly check if the incoming request is a post request, and I only want to proceed in that case, because in that case I, for example, also know that I can extract data from the request body. Because, for example, GET requests would not carry any data. So with that, we can extract data from the request body, and we can do this with the request body field, as you learned. Here we could then expect that we have an email field, and that's up to you. You are the developer of this site, so it's up to you how you transmit your data. And I will therefore expect an email field. So the user email is then extracted from the incoming request. Now here we could then also validate this and check if it's maybe not valid, or if email, user email I mean, does maybe not include a @ symbol, which is a very basic email validation. You might want to implement a more thorough one, but it's a start. And such server-side validation is optional but strongly recommended. Because even if you add validation and checks in your front-end code, those validation steps can always be circumvented. After all your front-end code is exposed to your users, so they could also manipulate it. So you shouldn't rely on front-end validation. Front-end validation is always just a convenience feature for your users. Instead, to really make sure that you get valid data and that you work with valid data, you should validate in your API route because this code can't be viewed or changed by your users. Now, for this task here, it's optional. I did not tell you to add such validation. So if you did not do that, that's totally fine. I just want to bring it up here because it is important to be aware of the role server-side validation plays. Now here we could then return to cancel the further function execution if we make it in here. So if we have invalid data, and we could return a response with a status code of 422, which is a status code signaling that the user input was bad, and then maybe set a message of invalid email address, something like this. And we would send this response back to the user if the input is invalid. And thereafter I return to cancel the function execution because I will add more code after this if check, and I don't want to execute that code if we have invalid input, hence the return statement. Now, if we do make it past this if block though, we know that we do have a valid user input, and then we could store it in a database or anything like that. For the moment, we'll not do this. For the moment, I'll just console log that user email. And that is now a first API route as we could write it. An API route for extracting an incoming email address. Now we want to send a request to this API route. And we want to do that from inside the components input folder, from inside the newsletter registration file. Here we have the registration handler, which is triggered when the form is submitted. And here I am preventing the browser default then to avoid that the page is reloaded. Now we could also validate the user input here and show an error message if it is invalid. Again, validation here is then just a convenience feature to show some feedback to the user quickly. It's not something you should rely on. And it's not something I will add here because it has nothing to do with API routes, but of course feel free to add it in your solution. Now, in my case here, I will not add it. I instead want to send the HTTP request to the API route we just added. And again, we can, for example, do this with the fetch function, which is built into the browser. Now, for the URL, you learned that the API route is hosted by the same server as our pages are sent back from, so it's the same domain. And hence we can just construct an absolute path to the API route with /API/newsletter in this case. /newsletter because I named my API route file newsletter. If you named it differently, you have to use a different identifier here in your URL. Now we want to send a post request because we need to add some data to the outgoing request. And hence here I'll add this configuration object to fetch, where we can set method to post and then add a body. Now speaking of that body, we need to get access to the input value here. And there are two main ways of doing that. We can add state and update the state with every keystroke, or we use a ref, and I'll do the latter since I only need access to the input once when the form is submitted. So for this, I'll use useRef, which we need to import from React. We can create our email input ref here, like this, and then connect it to the input element by adding the special ref prop and pointing at email input ref, like that. Now this is connected, and now here we can extract our entered email inside of this registration handler. We can get the entered email by reaching out to the email input ref.current, because that's how refs work, .value, to get the currently entered value. And that's then what I want to send to the backend. Now we need to send our data as JSON data here. So I'll call JSON stringify, and I'll pass in an object where I set an email property to entered email. And this should be an email property because in the API route, I'm extracting an email property on my body. So I'm looking for an email property in my body. So if you chose a different identifier here for extracting the data, you also need to choose a different property when you send the data. I'm using email, so I'm using it in both places. And then last but not least, I'll add headers and set a special content type header like this, and set this to application JSON to make the API routes aware of the type of data my request body will carry. And that will be JSON data because I convert my data to JSON with JSON stringify. So this sends a request to the API route. And now we can, of course, handle the response and then the response data if we want to. So here I'll just get access to the response data by calling the JSON method. And then here we can console log the data to just console log the response. And speaking of the response, there's one thing missing in the API route. I do send a response here if we have an invalid email address, but we should absolutely also send a response if we have a valid one. So in this scenario, after console logging the entered email, I'll send a response with a status code of 201, which means success, a resource was added, so the email was stored. And then we can, send back any kind of data, like for example, a JSON object, so a JavaScript object converted to JSON with help of that JSON method, where we add a message property where we could say signed up. Anything like this. If we do that and save this, we can check if this works. If we reload our application and open our developer tools, if I enter something invalid here, I get a warning from my browser actually, because this is of type email. So we have to add something valid here as well, though that could be disabled in the browser, so we should not rely on it. But if I do enter a valid email address here and I click register, that's looking good because I'm printing that response data here, which says signed up. And in the network tab, we also see that this request was sent successfully and that we got this 201 status code back. And if we have a look at our server-side terminal here, so this terminal where we started npm run dev, where all our server-side logs will be printed, we see that test@test.com is output here, and that makes sense because we are console logging the arriving email address here in our API route. So this is now working, and you can certainly enhance this and improve error handling or do anything like that, but this is the core functionality which you should add here as your first task. Now we worked on the newsletter registration. Let's now work on the comments area for our individual events. Here the goal is to again add an API route which accepts incoming data, this entered data, and then for the moment just logs it to the console, but which in addition also returns data for GET requests. And the API route should be dynamic because the ID of the event to which the comment belongs should be encoded in the URL. That was part of the instructions. Hence, I'll add another API route in the Pages API folder, and I'll use square brackets in the file name here, since it will be a dynamic API route. And I'll name my dynamic path segment identifier here event ID, because that is what should be encoded in the URL. Now we could leave it here, but I will actually create that file in a comments folder so that the full API route to reach that file and to execute the code in that file will later be /comments/some event ID. Because I think that is easier to read and makes more sense than just /some event ID. There it's not clear that this refers to comments. If the full path is /comments/some event ID, that makes more sense. And of course there's /API in front of all of that. So therefore here we can again define our handler function, which gets a request and a response, and export that inside of this event ID file, like this. And now in there we need to handle two different cases. The case that it's a post request which we get, and the case that it's a get request. Hence again we can check the request method here, and check if it's post and then do something. And then also check else if, or in another if statement thereafter, if request method is get. And if it's something totally else, we do nothing, and therefore we don't return a valid response. But that's fine, because for this application we don't intend any other usage. So now here we support post and get requests, and we can now implement the different logic. Now in both cases we need to know for which event we should add a comment or return the comments. That's why we made this dynamic. And hence, before we dive into any if block, we can already retrieve the event ID from request query. That's what you learned in the last section. This is how you can get access to the concrete value entered in the path as a value for this placeholder. So here it's request query .event ID, because I chose event ID, written like this, between my square brackets. If you chose a different identifier here, you have to choose a different property here. Now with that I get my event ID though. Now what we want to do differs on which request method we have though. If it's a post request, we get data for a new comment. So then we want to add server-side validation here, because I mentioned that you can't trust client-side validation. Therefore here I will add server-side validation and check if the entered data is correct. For this we first of all need to extract the entered data, so the data which is part of the incoming request, from the request body. And here I expect to get 3 pieces of data, which I'll pull out of the request body with object destructuring. I expect to get the email address of the user who left a comment, the name of the user, and then the comment text. And therefore, of course, when we later send a request from the client, so from the front-end code, we need to make sure that we include exactly these 3 properties into our request data. That's our responsibility later. With that, we'll then be able to extract it like this from the incoming request body. And then we can add validation logic. We can check if not the email address includes an @ symbol, or if we don't have a valid name, or if name, if we trim it, is equal to an empty string, which would also be invalid, or if we don't have a text, or if the text, if we trim it, is equal to an empty string. If any of those conditions here is met, the input is invalid, and then I want to return. I don't want to continue with the function execution, and I then also want to send back a response with a status code of 422, which stands for invalid input, and some message of our choice. For example, we could say invalid input. Of course, you could add a more elaborate validation, but that's good enough for now. So with that, we validate the user input. As a next step, after this if check, but still in the post method if check, we wanna do something. And for the moment, again, I'll just console log the data which we received. So I will console log email, name, and text here. We will soon do something more useful, but for the moment, that's it. Thereafter, I want to send back a response with a status code of 201, because we will have created a new comment. We don't actually do it here, but we will soon do so, and send back some data in JSON format, where we could send back a message of added comment. And actually, we can create a new comment object here, a new JavaScript object, with some random ID. For the moment, I'll just use the current date timestamp to create a dummy ID. We will also soon have a better ID, but for the moment, that's good enough. And then add email, name, and text here as fields in that object. And therefore, then, as part of the response, not just send back the message, but also the comment that was created, that new comment. So that we create it here and we send it back. And actually then we can also log that new comment here instead of the individual inputs. So that is then my actual logic for this case, for the post case. Now, if we get a GET request, we want to send back a list of comments. At the moment, we have no such list because we have no data source, no database yet. And therefore, at the moment, I will just create a dummy list of comments, which is an array where I add a couple of dummy comments with an ID, a name for the user, and an email address like this, and then also the comment data. Actually, we don't even need to add an email address because we will not use that on the front end anyways when displaying the comments. So here, let's maybe also name this text. And then let's add a text like a first comment here. And then add a second comment with C2 by manual, where I say a second comment. And of course, it shouldn't be a fist, but a first comment. Okay, so that's my dummy list of comments, which we will later replace with an actual list coming from a database. But for the moment, it's this. And then we send back a response with a status code of 200 with some JSON encoded data, where we have our comments, which is just this list of dummy comments for the moment. And that's the API route for the comments feature. Now let's send the appropriate requests from the front end. So from the front end, we want to send requests to our newly added comments API route. And it's the new comments component where I want to start with this. Here we have the send comment handler, and in there we get all that user input, and we then have some client-side validation, which we shouldn't trust, but which is still there. And we then call onAddComment on props, which should be a function, where we pass an object with email, name, and text. And onAddComment then in the end is a function here in the comments.js file, this add comment handler, which is passed as a function through the onAddComment prop on the new comment component. And here we then receive that comment data, which should be sent as a request. Now I actually do need to connect my send comment handler to the form. So here with onSubmit, I point at send comment handler to connect that. And then in comments.js, we want to send a request. So here again, we can use the fetch function for this, and the route now is /API/ and then it's comments, because of that comments folder, / and then this file, but of course with a concrete value for the event ID. Now that event ID is something which we get through props here in the comments component. It's in the end passed in by this page, by this event ID page, so this real page, not the API route, but this real page. There into comments, I pass in this event prop, which points at the ID of the event we're loading here. Hence, in the comments.js file, we get this event ID prop, and that is what we should add as a concrete value to the route here, to the path. Then it should be a post request. Hence, we add this second argument to configure the request and set the method to post and the body then to our data. And here I'll use JSON stringify to send my comment data, which is this data package we get from the new comment component, which contains email, name, and text. And here I'm using these property names, email, name, and text, and hence it's these property names which you should be looking for in your API route, email, name, and text, so that the data can be retrieved correctly, because I'm just forwarding that data with my HTTP request to the API route. Then I'll add these extra headers to clarify the content type I'm sending here, application JSON, and we should be good. Now we can again wait for a response and parse that. And then as a next step, thereafter, get back some data, which we, for example, console log, like this. With all that implemented, if we save everything and go back, if I try to submit this empty form, I get an error here, because I have some built-in client-side validation. If I disable this client-side validation, if I go to the new comments.js file and I comment out this code here, and I submit this, it is submitted, but now in the network tab, if we open that and submit this, we see that the request actually fails, it's red, and it has this 422 status code, which we do send back from the API route if our server-side validation fails. And that server-side validation, unlike the client-side application, can't be tricked. So it is good to add logic like this. Nonetheless, I'll bring back that client-side validation because, of course, for the user experience, it's better if we already validate the data and show an error before we even send a request. So with that back, let's now enter some valid data here. Let's enter an email address and a name and some text. This is my comment, and click submit. And now this succeeds. We have the 201 status code. And in the response, we see the message and this comment object with the dummy ID, which was created on the backend. We're also logging it in the console here. So this works, and if we have a look at the server-side log, so the terminal where we run npm run dev, we also see that object here. So that works, and we do send that data. Now, last but not least, before we then add some real logic talking to a database to our API route, let's also fetch comments in the comments.js file when we do show our comments. Now, for showing the comments, we have the toggle comments handler, and that is executed whenever this button here is clicked. And whenever we do show comments, I want to load the comments by sending a GET request to this comments API route. So I want to trigger this part of this handler function then. And to achieve this, we got various different ways. We could go into this toggle comments handler function, for example, and here we change the state, but this will not be processed instantly by React. It will be scheduled, and in the next line thereafter, the state will not be updated yet. So here we could check if show comments is true, which means the current state is show comments, then the button was clicked and this function executes again. So the goal is to hide them now. And therefore we could check if not show comments, which means the current state is that the comments are not shown, then this function executes, and the new state is that they will be shown. So now we should fetch data, and that's something we could do. Or alternatively, we use good old use effect here, and also import that from React. And in here, simply add show comments as a dependency. And in the effect function, we then check if show comments is true, which means that comments are shown. And if that is true, we want to fetch the comments. So then here we can send our request to /API/comments/event ID. So this concrete event ID. We don't need to configure it because it will be a GET request, not a POST request. So the default is fine. And then we also get our data and parse that so that we have the real data here eventually with which we can work. Now, once we got that data, we want to use the data to set the actual comments which should be rendered here with help of comment list. So for that, we can manage another piece of state with use state, a list of comments where I have my comments and set comments to update them like this. And I want to set comments once I get them. So here in this then block, once we got a response, I'll set my comments. And in the API route, we send back an object with a comments key which then contains this array of comments. So when we work with that data, I want to set comments equal to data.comments to access that array of comments, which is set in that response data package, which has this comments key, as we just saw. That then sets that comments state to those fetched comments. And that means that we can then use them to render them. So this comments state could then be passed to comment list, let's say through an items prop, like this. And now in comment list, we need to work with this items prop. And of course, you can name that prop differently. In there, I'm not expecting any props right now, but we should change this, add the props parameter, and extract items from props. And then we can use items to render these list items dynamically. So we just go through items and map every item into a list item with content like this. So cut this and add it here and get rid of these dummy list items down there. And then here add a key on every list item, which should be item.id. Here as a text, we want to output item.text. And for the address here, we want to output item.name, so the name of the user who wrote the comment. With that, we have our list items, which should be rendered, and we can now check whether that works. Let's reload this page for a single event and click on Show Comments. And we see the comments showing up there. And in the Network tab, we can also see the request there. If I hide the comments and I click Show again, they are fetched again. And hence we see the request here, and we see that it carries the comments in the response. I guess that's kind of obvious because we also render them successfully here, so it clearly works. And these are the core tasks which I gave you solved. We added the newsletter registration and now also this comments feature for storing comments, or for at least submitting the comments, I guess, and for fetching the dummy comments. Now, it's not very realistic yet, though, because we are only working with dummy data and we're not storing the submitted comment anywhere. Therefore, in a next step, let me show you an example of how we could talk to a real database to store our data there and to get our data from there. So now that we added our API routes for the newsletter and for the comments, and that we wired up those front-end components for the newsletter and for the comments, now that all of that was done, it's time to work on the logic inside of the API routes. Because at the moment, we don't do anything in there. In the newsletter API route, we're just logging the entered email. And in the comments API route, for the post case, we also, in the end, just log our comment here. And that, of course, is not too helpful. That's not the goal. Instead, we want to store that data more permanently. And we could, of course, use a file for that. We could re-add a data folder in our project with some JSON or text file and write that data to that file. But I would argue it's more realistic to use a database, and therefore that's what we'll do. I'll use a real database here. I'll use MongoDB. MongoDB, of course, is just one option. It's not a must-use option, but I will use it because using MongoDB with Node.js is particularly easy, and it's also a production-ready, scalable database, which is a great choice for pretty much all projects, for a lot of projects. Let's put it like this. And that's why we'll use MongoDB. Even better than that, we can get started for free. If you visit mongodb.com and you go to pricing, you'll see that they have various offerings, and we will use the cloud service here, MongoDB Atlas. That is their fully managed cloud database service, which we can use without setting up anything on our local system, which is great. And we can get started for free here, which is awesome. So we can click on Start Free here, actually. Or in the top right corner, click on Try Free, click on Cloud then, and then get started for free here by signing up. Just fill out these basic details and sign up. I already do have an account, so I will log in with that. And once you did sign up and log in, you should be greeted with some screen that looks something like this. You should be able to build a cluster and then there use a shared cluster. So create a cluster here where you can get started for free. Now, a cluster is basically a server, you could say, which will then later host your databases, you could say. Now here we need to choose a cloud provider, which will be used under the hood. And we can stick to AWS here and basically keep the defaults. For cluster tier, let's stick to the M0 sandbox since that's available for free. And for the additional settings, we also can stick to the defaults, and we can also keep that default cluster name and create that cluster. Now this will set up this database cluster, which will then enable us to connect to this cluster and store data in the databases there. And using it will be super simple. Now, whilst this is getting set up, we can go back to our project already and quit the dev server and install an extra package with npm install. Because in order to communicate with MongoDB and to send queries to MongoDB, we need to install a new third-party package. If you search for Node.js MongoDB, you also find it on npm. It's this MongoDB package, which is the official driver for MongoDB. So that makes connecting and talking to the MongoDB database super easy then. So we should install MongoDB, this MongoDB package here like this with npm install MongoDB. And this will install this third-party package, which we'll then use in our server-side code to talk to MongoDB, to our cluster, and to store data. And to fetch data as well, of course. And the important thing here really is that we'll use it in our server-side code. So in these API routes. We will not use this MongoDB package in any client-side code. Because it's not optimized for that. It might not even work there because there is a high chance that it uses Node.js APIs internally. And B, even if it does work in the browser, it would be a security issue. Because for talking to the database, we will need to plug our credentials into the code, and we don't want to do that in any code our users can see, because they could then abuse those credentials to hack into our database. That's why we want to run such database code only on the server side, so only in our API routes. Now, connecting to the cluster is done here now. And when we clicked on connect, we can choose connect your application and we see code which we can use to connect to our MongoDB cluster with the Node.js driver here. And that's what we're going to do in the next lectures. So let's now connect to our MongoDB cluster and let's, run some code against it. And let's maybe start with the newsletter API route. I will bring back my development server with npm run dev. And now here in the newsletter API route, I want to store that email address in a table, or as it's called in MongoDB, a collection of email addresses. So that we have a collection of email addresses stored in the database. And that then could be used by us to send out newsletters and emails of any kind to those registered users. Now, to do that, we'll need to do two things. We need to connect to the database. And once we are connected, we need to run an insert command to insert the email address into some collection. Now we can learn more about that on the official docs and also on the npm docs of the MongoDB driver already. If we scroll down to quick start, there we see that we have some code here for connecting, and that when we are connected, we can insert documents as they are called, so entries into the collection with insert many or also with another command, which we'll see. So let's connect to MongoDB. And for that, we can use this code. though we can also adjust it here in newsletter.js. We can use ES module imports, and we can import something from MongoDB like this. And the something I want to import is Mongo client between curly braces. With that imported, we can use it down here to set up a connection. So here we can then use Mongo client, and as we see here in the docs, call the connect method to connect to a database. So here I'll then call connect, and now we need to pass in our connection URL. Now for that, we can go back to the cluster because here we got this URL. So we can copy this URL here, and I got there by clicking on connect and then connect your application. So I'll copy that URL and paste it in here as a string. Now here we need to fill in a username, a password, and a database name. Now for a username and password, you should go to database access here and add a new database user with password, with any username and password of your choice. So fill in any values here, and then with read and write access to any database. Now I already did create such a user, so I'll just edit my existing user and assign a new password, which I'll also change once this recording is done, so you can't use that user and that password. So I will use that user and password, and hence here in my case, I'll use Maximilian as a username. Make sure to also get rid of those angle brackets here in those placeholders, and plug in my password as well. Now for the database name, you can choose any database name you want, because that database of that name will then be created automatically once you start sending queries. And here I'll name it newsletter. Now there's one other setting we need to adjust. In MongoDB Atlas under network access, you want to add an IP address and make sure that you add your current IP address to that whitelist here. You should do that to ensure that your local machine is able to send requests to that MongoDB Atlas cluster. Once you deploy your application, you want to make sure that the server you deployed your site to is whitelisted here. Otherwise, incoming requests will be blocked. So that's something we need to do. And with that, we got this connect string configured. Now, the connect method takes a second argument, which is a callback, which gives us access to the connected client, so to the cluster in the end, once the connection was established. Alternatively, we don't add a second argument and instead add a then block to use a promise returned by connect, which also gives us access to the client once the connection was established. That would also allow us to use async await here if we wanted to. Now we can only talk to the database once the connection was established, so only inside of this then block here in this case. So only in this function where we do have access to the client. That's also what we see in this quick start guide here. There they are using the callback function, but we can use the promise as well. Now in here, we want to get access to the concrete database to which we connected, and we do this by executing client.db. We could enter the database name here, but since we already encoded that in the connection string, we don't need to do that. We can just leave that blank, and we'll use that database to which we connected with the connection string. And once we got hold of the database with the db method, we can use the database to get access to a collection, which is like a table in that database into which we want to store data. And that could be the emails collection in the newsletter database, which will then hold the individual email addresses. Now it's that collection against which we can now run our queries. For example, the insert one query to insert one new entry into that collection. And entries in collections are called documents in MongoDB world. And a document should be a JavaScript object here. And then it can have any key value pairs of your choice. And here I'll have an email field, let's say, which just contains that user email value, which I extracted and validated here. So now I'll insert such a document into this collection. Now this also returns a promise, which will let us know once it's done. And therefore, since we're already in a then chain, we can just return this promise here to add another then block thereafter and continue. However, I'll switch to async await now, since that is a bit easier. And we can do that by adding async in front of our handler function, because these API route handler functions are allowed to be async. They can be async. So I'll add async here. And then I'll switch this all to async await by awaiting the connect method here and getting my client like this. And then removing this here and this here. And then instead of returning here, I will await this insert operation like that. So now we're using async await for connecting, for getting access to the database, and for inserting one document. And then once we're done with all of that, I will send back that status code. We should just do one other thing. We should also use the client again and call close to disconnect from that client. Now with all of that, we should be inserting a new email address into that emails collection in our newsletter database. If we save all that code now, and we go back to our application, to our site on localhost 3000, let's test this. Let me enter a new email address and click register. And we don't get any feedback here. We could, of course, add some, but let's see whether it worked by going to our cluster, and there we can click on collections to see the collections that are part of this cluster. And there you should see a newsletter database with the emails collection. And then inside of that emails collection here on the right, you see that document which we inserted with that email address. It also has an automatically assigned unique ID. And that shows us that everything works. We also got no error here in the terminal, just some warnings which we can ignore here. And therefore, that is how we can now talk to a real database to store our emails. As mentioned, we could now again work on the front end a little bit and provide a better feedback to the user here, but I will not dive into that here since I want to focus on these API routes, since it is these API routes which are the core feature we're looking at here. So now that we're storing a newsletter successfully, let's also store and fetch our comments. For this, I'll go back to the comments API route. And now here we also want to connect with MongoDB and then simply insert a new comment or fetch all comments. So either way, no matter what happens, we want to connect to MongoDB. So before we dive into any if block here, I want to set up my connection. Hence, we need to import Mongo client from MongoDB here, and then repeat the code from before. And of course, we therefore could also look into creating some helper functions, but I will just quickly repeat that. Mongo client connect, and then grab my connection string from the newsletter.js file, paste that in here. And again, I'll use async await, so add async in front of the handler function and await this connection to get access to the client. Now already, after all these if checks, I will go down there and already call client close to make sure that we don't forget this, that we close the connection once we're done with our logic, no matter what our logic was. So now that's that. Now inside of request method post, we want to store our comment here in our database. And for this, I'll create my new comment, but then thereafter, I will use the client and the DB method to get access to the database to which we connected. And for that, actually, I want to adjust the connection string here and not connect to a newsletter database, but instead to my comments database. Or overall, we connect to our events database for the events application. And then we have our emails collection and we have our comments collection. And I think that makes more sense. So I'll connect to the events database in the newsletter.js file as well, and connect to the same database here in the comments API route events. So then it's this database with which will work. And on that database, I then use the emails collection in the newsletter.js file, or maybe let's now name the collection newsletter, but that's of course up to you. And in the comments event ID file here, I'll connect or I'll work with a collection named comments. And here I now want to insert one new comment. Now it is this comment, but I want to tweak that comment object. I don't want to create my dummy ID anymore because MongoDB will create a unique ID for me, so I don't need to assign my own ID. But instead I want to do something which I haven't done up to this point. I want to use this event ID which we're getting, which is encoded in the URL. And I want to make it clear to which event my comment is related. Because in reality, we would probably manage our events with MongoDB as well. We're not doing that here, but in reality, we would probably manage them in the database as well. So then storing the ID of the related document in some other collection in this document here would make a lot of sense. And that's therefore what I'll do. I'll store event ID as an extra property in the new comment to have this reference to the event to which this comment belongs. And then it's this new comment which I want to insert. So here I'll insert one and I'll insert this new comment. And of course, await this operation. Now we do get back some response here, by the way, some result of that insert one operation. And I will console log that result for now. And therefore, that's now my code here in the post case, so that we add a new comment. Before we work on the get case here, let's save that code and let's see whether it works and makes sense. For this, I'll dive into an individual event, show my comments, and add a new comment with some dummy data. This is a test with MongoDB. Click submit. We still get no feedback here. We could add it, but we haven't done anything in that direction. But if I go to the backend, that looks good. I got an output here. That's this result which I'm logging. Whoops. This result which I'm logging. That's what we see here. And we see that it's quite a long result, quite a detailed output, because result in case of insert one is actually containing full details about the operation that was performed, but then also the connection in general and much, much more. Now what we can see if we go to the cluster is that here, if we reload this page to refresh the data, we got this events database now with a comments collection, and in there we indeed see that comment which I just added. So it was stored successfully in the database. Now what's also interesting on the result is that on the result we also get back that unique ID which was generated automatically. That's interesting because that means that on the new comment object which we stored in the database, we can now add a ID field and set this equal to result.insertedID. So that the new comment which we sent back to the front end also contains this unique ID that was generated. I guess that's convenient to have in case we would work with that inserted comment on the front end right away. So that's now the post case. Let's now work on the get method, where we get our comments. Here we currently return that dummy list of comments, and that's of course not the goal. Let's remove that. Instead, we want to work with our client. So this client, which we got from connecting up here, we want to work with that. And in the get case here, we also want to get access to the database to which we connected, like this. And then on that database, reach out to the comments collection. So of course, the same collection we are working on here. Now, instead of calling insert one, we want to get all the documents in there, and we can do this with help of the find method. The find method finds us data in a collection, and we can restrict the results. We can narrow down the results and we can filter results. But if we call find like this, we will fetch all the comments, and that's the goal here. In case you want to learn more about MongoDB, I strongly recommend my MongoDB course, which is a full course on MongoDB only. So that might be worth a look then. Here we'll keep it basic and just find all documents. So here we get the documents by awaiting that operation. And to be precise here, we want to call toArray to get all the documents as an array. Because by default, we would not be getting such an array. We would be getting a cursor with which we have to navigate through documents manually. And calling toArray simplifies that and simply gives us all the entries in the comments collection as an array. Actually, before doing that, I want to call sort on find. So on the result of find, I will call sort, because sort allows us to, well, sort the results. And we do sort by passing an object to sort, where we then specify one of our keys in our documents, or for example, _ID for the automatically added ID, and then minus or +1 to define if we want to sort in descending or ascending order. And I want to sort the IDs in descending order, which we can do by adding _ID and setting it to a value of -1. This will sort the comments which we're fetching in descending order so that the latest comment is the first comment in this array which we're fetching. So that's now our documents which we get as an array. And hence, let's now return our documents here and see what we get. If we save this and we go back to our front end, if we open the console there, the developer tools, and I hide the comments and show them again, we're fetching data again, and now I'm getting a warning regarding my key, but we see the comment, so that works. We're only getting that comment here, that warning I mean, because if we have a look at the network tab, we see that the comments we're fetching have that _ID field. Of course, because that was auto-generated by MongoDB. But in my front-end code here, for the comments, in components, input, comment list, I'm referring to .id without an underscore. So the simple fix is to add an underscore here so that we use the correct field as a key for the list items. And if we do that and save this and reload, you will see that we'll not get any warning anymore. Instead, our comments do show up correctly here. Now, we could, of course, improve the front end. We could show a loading spinner whilst we're fetching. We could show some feedback after we submitted our form. But again, I want to focus on Next.js and the API routes here, which is why I only provided this basic front end for the moment. But what we can see with all of that is that working with our API routes works, and that we are able to work with MongoDB in there, so that we are able to connect our API routes and the code running in there to a real MongoDB database. Now that we implemented our MongoDB logic, let's wrap up this course section by adding some error handling to the API routes, because that is also something you should know how to do. When you run server-side code, things don't always go right. And at the moment, we assume that everything works. Like here, when we store a newsletter. When we do that, we check the request method, check that it's a post method, and if it is, we basically just validate the input. That's one case where we send back an error status code if it's not valid. But for working with the database, we just assume that everything works. And that's unrealistic. Things won't always work. Connecting to the database could fail, or even if we are connected, inserting data could fail for whatever reason. because the database servers went down temporarily just when we tried to insert data. Things can fail, no matter how unlikely that might be. So how do we deal with that then? Well, since I'm using async await here, we can use try catch to try certain operations, catch errors, and then send back a response if things go wrong. And here I actually want to work with two different try catch blocks. I want to try connecting, and if that fails, I want to send back an error. But if it succeeds, I want to try this code. So inserting, I want to try that. And if that fails, I want to send back an error, a different error, and I then also still want to close the open connection. And to do this in an elegant way, I'll work with some helper functions. For that, I'll add a new function, which I'll name connect database. The name is up to you, of course. And this function here will just hold this code for establishing a connection. So I'll put that in here and then just return the client. And I'll add another function, which I'll name insert document, where I expect to get access to the client and where I get the document that should be inserted as parameters. And inside of insert document, I then want to run this code here. So I'll copy that into insert document. And of course, in order to use await, this should be an async function, and this here should be an async function as well. Connect database. Now with that done, down here in our main handler function, I get the client by calling connect database, and then I will call insert document, pass my client as a first argument, and that document here as a second argument. Now I want to await connect database because it is a async function, so it returns a promise, and we need to wait for this connection to be established. And for the same reason, we also want to await insert document, because that's also an async operation. Now with that outsourced, to make this code a bit more readable, I will wrap connecting with try and catch potential errors here. And I'll then do the same for inserting here. I'll also wrap this with try and catch errors here. Now I want to call client close if we did connect successfully, but we failed to insert. So I want to call client close inside of this try block here as well. And to make sure that client is available here, I'll set it as a variable here and set it to a value in the first try block. And if we make it past this block, client will be the connected database. So calling close will work then. And then here we got the different errors. If we fail to connect, I want to send back a response where I set the status code to 500, which indicates that something went wrong on this server, which clearly is the case here. And I'll send back an object as JSON, which has a message where I say connecting to the database failed. And if that failed, I don't want to continue with the other code. I don't want to continue with this try catch block, and I certainly don't want to send back this response eventually. Hence here I'll return then to prevent further function execution. I'll do something similar here if we fail to insert. I'll copy that code, but I'll set the message to inserting data failed. And that's how we can handle errors here. If we make it past both try catch blocks, so if we don't go into any of these catch blocks to be precise, we will still send back that success response. Now to check whether that works, we can temporarily break this connect database function by using incorrect credentials, like a username that doesn't exist. I save that and I go back to the newsletter part here. If I try to sign up with some dummy newsletter, we see that we get back an error here. In the network tab, we also see it. we see that we got back a response with a status code of 500, where the message we get is connecting to the database failed. Now, as mentioned before, we don't have any feedback on the user interface, and you might, of course, want to add such feedback also for the loading state and so on. I just didn't focus on this at the moment because I want to thoroughly dive into API routes. And there we can see that our error handling works. If I go back to a correct username and we try that same request again, I still get an error. Inserting data failed is what I get now. That's unintended, but good to know. Let's see what went wrong there. And the problem here is a simple error I made in this extra insert document function. I'm accepting client and document. Well, I should be using that document for inserting data instead of having my hard-coded document there as I had before, where I referenced user email, which is just not available. I should be using the document we get as a parameter. So, still nice to see that this error handling also worked, but with that fixed, if we now try this again, now that's looking better. We get a success response here, and it works. So that's how we can add error handling here. Now let's also add it to the other API route. There we can do something similar. We can create separate functions for connecting and inserting, and since we would be reusing the same logic, we might want to go for some helper functions instead. We got that helpers folder anyways with some API utilities, and there we can add a db-util.js file to set up our database utility functions. And I'll then go to the newsletter.js file and grab the connect database and insert document functions, cut them from newsletter.js, and instead add them in db-util, and just change the insert document function such that it also takes the collection as a parameter, so that we don't always talk to the newsletter collection here, but to any collection we get as a parameter. Now we want to export both functions so that we can import them into other files. And then we can use them here in newsletter.js. There we can now import from our db-util file by going up to the helpers, db-util, and here I'll import connect database and insert document. And for insert document, we now just also need to pass in that collection name as a second argument so that the email is inserted into the correct collection. And with that, we can go to the event ID file here and also import these two functions here. So from the helpers folder, we want to import from the db-util file. And here we also want to import connect database and insert document and then use that. Here, for example, we connect to the database. So here we want to await connect database like this to get access to the client. Now this could be failing, so just as before, I will wrap it in a try catch block, catch any error we might be getting, like that, and create client as a variable, which we then set in here. And then in here, we want to send back a response with a status code of 500 and some message in the JSON body that could be connecting to the database failed, like this, and then still return to avoid that the rest of this function executes. If we do connect successfully down here for inserting the comment, we don't want to run this code here. Instead, we want to execute insert document, pass the client to insert document, use the comments collection, and pass the new comment as a document that should be inserted, and await to get access to the result. For that, we want to make sure that in db-util, we actually do return that result, so that here we also grab that result and return it, like that. With that, we can insert the document and still use the result to then update the ID. Here, we, by the way, also might want to use _ID to be in line with the automatically generated field, because there the field name is also _ID, as you saw in the last lectures. Now, the main goal was to add error handling though, and hence I'll wrap this into a try-catch block as well, catch any potential errors, return to not execute any other code if that did fail, and then send back a status code of 500 and some response data where we again could add a message of inserting comment failed. And now I just want to create result as a variable, which I actually set here to get scoping right. Now the only remaining part is where we get our data. We can also create a helper function for that, even though we only use it here, but still to have a uniform approach when it comes to working with the database. I will go to the db-util file and export another async function. Get all documents sounds like a fitting name. And here I also need the client and the collection from which I want to get all documents. And then we can take this code where we get access to the database and then fetch all entries in comments and paste that into get all documents. Now, actually, we might want to accept sort, this sort object, as an argument as well to make this function more flexible and let the caller of the function specify how documents should be sorted. Then we want to use collection here and use the sort parameter here and ultimately, of course, return our documents like this. Now in the event ID file, we can import this newly added getAllDocuments function from the db-util file and use it down there. Here in the get case, I want to call getAllDocuments, pass in my client, pass in my collection name, which is comments, and pass in my sort object, which defines that I want to sort by ID in descending order. Then we can remove this and await getAllDocuments to get all our documents here like this and return our response. But again, we want to add error handling so we can try this and catch any errors if something goes wrong here, in which case we stop function execution with return and then return a different response where the status code is set to 500 and we pass on some message. For example, here we could say getting comments failed. Now you will be able to refactor more. For example, sending back that error response is always pretty much the same. You could also create a separate function for that, just as a side note. Now with that, we get our documents here, and I want to send back a response here if that all works. Otherwise, we send back that error response. And we then close the client. And actually, now that I moved this success response into the try block, we can remove this return statement to make sure that we do close the client if we make it past try catch here. So to make sure that we do always get rid of that connection once we're done with our operations. And actually, I want to do something similar here for inserting a comment. Move this success code into the try block and then don't return here so that we still do reach this part at the bottom eventually where we do close the connection. That's why I like this way of handling it better. I also want to close the connection here if we have invalid input, so I'll copy client close and add it in there. Because here I then want to return, I don't want to continue with code execution, hence here I want to close the client, so close the connection. And here we don't want to close the connection because here establishing the connection failed already. So here we definitely want to return. And with all of that, we can again test this again by breaking our credentials, then go to a single event and show the comments. And fetching them fails now. And this breaks the front-end application actually, because now we're trying to map through all comments, even though we got no comments. So we might want to add better error handling on the front end as well. For the moment, I'll just fix it by bringing back my credentials and reloading. Now this still fails. So it seems like something is wrong. Now let's see what's wrong by reloading with the network tab open. And then if I click on show comments, this request still fails. Connecting to the database failed here. Even though I fixed my credentials again. Even though I did that, it looks like calling connect database failed in my handler function here. And actually, I know what went wrong. I moved my function here, my helper functions here into the db-util file, but there I'm referring to Mongo client. We need to add that import. So we should grab that Mongo client import and remove it from the newsletter file. We don't need it there anymore. Same is true for the event ID file in the comments folder. We can get rid of it there, but we should add this import in the db-util.js file because we are using Mongo client there. That's why connecting failed. I was referring to Mongo client without having it available. So now with that, if we now reload, loading the comments works. And if I now break my credentials here and save this, if I now try to submit a new comment, this should fail. And it does. So that works. Again, no feedback on the front end. We could add it. We don't have it here. If I bring back my correct credentials and I try the same data again, this now worked. And if I now hide the comments and show them again, we see that both comments are loaded as well. So that is all working here, and we now did also add error handling therefore. Now that is it for this course section. As mentioned multiple times throughout the section, you can absolutely work on the front end. You can improve the feedback, the user interface there. You can show a loading and an error state and give the user better feedback about what's happening. That's all standard React, not Next specific and definitely not API route specific. This module was about practicing API routes though. And here you learned a lot about them. You again saw that you can create static and dynamic API routes, where data is encoded in the URL. And you learned how you add your own API routes, that you can run any server-side logic you want in there, and that you can, for example, use them to connect to a real database. In this case, to MongoDB. You then learned that you can send back different responses, both error and success responses, and how you can manage your code flow and the function execution with your different return statements, with the different responses, and with different if checks, for example, by checking for the request method. Being able to use API routes is very important because for a lot of websites and web applications you will be building, you don't just want to have pages that can be pre-rendered, but you often do want certain server-side logic that should be executed on demand. For example, when a user signs up for a newsletter or leaves a comment, just as we added it here.